Got another question in this week that was sent to me. Now, I'm going to start off this way. What exactly do you do, and what is predictive analytics? Signed, your mom. I'm going to tell you, fill you in and fill everybody in. And I got a little help to do it. Let's get to it. Welcome. I'm your not so humble but very passionate host, Eric Wilson, and this is IBF On Demand, your podcast coming to you on YouTube or wherever you get your podcast. We do have a sponsor for this, Arkieva, your one-source S&OP software solution. So please check them out. They've been involved with us from the beginning. Great opportunity to see exactly what they have to offer you as well. And I want you to keep watching. I know we're going to be hitting about the 5-minute mark now, and analytics-wise, people start dropping off. So you know who you are. So help me boost these analytics. Just sit and watch the entire episode once or twice or 5 times. Really get those up. And continue to like, share, and subscribe. We're almost at the 2,000 mark with subscribers. I want to get over that level. So please, if you haven't subscribed, please subscribe. And do me one more favor. When you do that sharing, get your other friends to subscribe as well, your other colleagues, because guess what? We're trying to grow a community here. This is a family. IBF is about a family. This podcast is about that family, giving you some insights into forecasting, business forecasting, S&OP, predictive analytics, things you're doing every day, giving you some insights on those. I said today we're going to talk a little bit about predictive analytics, what it is, and answer the question of what exactly I do or you do. Because you know it's a tough question. When you're at the pool, you're going to a party, someone asks you, what is it exactly you do? And you start talking, I do business forecasting, and their eyes just glaze over. So what exactly is we do? Can we answer that question? I'm going to try to help you explain that. And I figured I need some help. And 2 Erics are much better than 1. So also gave me an excuse to bring him on. So we have a very special guest today. Eric Siegel. He's the instructor of our Coursera Machine Learning for Everyone course. He's the former Columbia University professor. He's a singer and songwriter, kind of, popularized with a geek rap video on YouTube about predictive analytics. He received numerous teaching awards. He's the author of the bestseller, Predictive Analytics, The Power to Predict Who Will Click, Buy, Lie, or Die. He's the founder of Predictive Analytics World Conference. He has appeared on talk shows and newscasts around the globe and almost equals my passion and makes predictive analytics and machine learning understandable and captivating. Help me welcome Eric Siegel. Welcome. So thank you very much, Eric, for joining me. I'm excited. I said I'm using this as an excuse to get you on our podcast to be able to talk. I've read your book a few times. I actually got the audio book as well because I read your book last year. And very conversational the way you write. It's an excellent way of writing it. I actually got your audio book to be able to freshen up for this, and it's equally as engaging and entertaining. So kudos on your book, and kudos to what you're doing right now with Coursera as well, putting together those courses. I'm excited. Actually, I'm probably participate in those as well and be able to gain my knowledge in machine learning for everyday use type situations. So thank you very much.
Thanks, Eric. Thanks for having me, and thanks for saying all that. Yeah, I mean, if you prefer to see the movie instead of read the book, although the movie, the Coursera course series, which is called Machine Learning for Everyone, is broader. It's got more content. It's composed of 141 short videos, so it's got a lot of content.
Well, I would check that out. Now I've done the book, I've done the audio, and now I'll do the movie now as well. So I'll do all 3.
Excellent. Yeah. You can watch it on the go, just like an audiobook, because Coursera's got that app, and it's free to access the entire contents.
I would check that out. So, I started off, you get this question a lot. You actually covered it in your book. And I'm going to have to ask it again for this audience because we got a lot of people out there still trying to figure out exactly what it is that we do. So I'm going to ask you the question I'm sure you've had is, can you please explain to people exactly what it is that we do? What is predictive analytics?
Right. Well, predictive analytics is basically applications of machine learning for business problems. So the way we kind of most concretely define it is it learns from data to render predictions for each individual. So in most cases, it's sort of differentiated. I mean, there's a continuum, a fuzzy boundary here between predictive analytics and forecasting. But I differentiate in that forecasting, you're usually talking about singular predictions. What's going to be the sales in the next quarter, and whether with politics, which direction is an election going to go? Whereas with predictive analytics, we're at this lower, more detailed level of granularity. So it's more for targeting marketing, for targeting fraud investigation, for deciding who should be granted approval on an application for a credit card or what have you. It's rendering a predictive score for each individual, which could be a consumer or a corporate client or even a product, which satellite is most likely to run out of battery over the next 2 years, things like that. But since you're rendering for each individual, you're directly informing decisions on that level of granularity. So it drives large-scale operations in fraud detection, marketing, credit risk management, et cetera. It drives all those large-scale operations, really all the main large-scale operations that we execute as organizations, more effectively. So there's a lot of overlap with forecasting. There should be a lot more interaction between what are really two very siloed industries, but there's a lot of the same concepts, a lot of the same core analytical methods, a lot of the same thinking. They certainly would both belong under this sort of subjective umbrella known as data science, right? So I'm glad you have you on, and also to hear about a book that you're writing where you're bringing the two fields together. What's the title of that book again?
Predictive Analytics for Business Forecasting. Yeah, it'll be out about a month from now. So thank you for that plug. So.
Yeah, sure.
So with that, I mean, so why exactly is then predictive analytics, machine learning? Why is it important, or why is it the latest evolution in information technology? Why is it that latest revolution in your opinion?
Well, I like to consider that it the latest step in that evolution, evolutionary step, kind of in the information age, because it drives all the large scale operations more effectively, right? So in a sense, we've moved from engineering, the sort of the big data movement of how to warehouse, manage, maintain, collect bigger and bigger data, to the application of science to learn from that data, its content, what it means. What do we want to learn from data? We want to learn how to predict. Predicting per individual is basically by definition the most actionable form of analytics, because it directly informs those per individual decisions, right? Which make up all the main large-scale operations that we conduct as organizations.
And you kind of mentioned that, I mean, it makes up all the large-scale operations. I mean, I've said quite a few times, every business decision starts with a forward-looking projection or a lag between what you know or assume right now and what actually occurs. Mm-hmm. That is a prediction.
And indeed, yes.
And being able to drive that prediction with data and science is pretty much what you're talking about, aren't you?
I mean, the only way to scale prediction, right, in general, and to optimize, to do it in a scientific way, is to do it with data and use, the best in class, cutting edge methods, which are known as machine learning, right? So the methods on the sort of business applications side include decision trees and logistic regression, neural networks, ensemble models, et cetera, right? And forecasting time series and stuff. But there's ways in which these two classes of methods really do interact and build upon one another.
Now, knowing this audience, we may have just scared a few people away.
No,
talking about ensemble models, regression.
No. They have fancy names, but they're totally intuitive. So let's plug our writing and stuff, right? So the name of the Coursera course, Machine Learning for Everyone, because we mean that. It is intuitive. There is a way to present it, and we've worked hard to do that so that it can be accessible, understandable, relevant, interesting, even entertaining to everyone. And the core technology is exciting because it provides this business value.
Yeah, and true. That's why I said I'm finding someone on this podcast that almost equals my passion for predictive analytics. So and if we can make it exciting and entertaining, that's the key right there.
My passion is bigger than yours. Definitely.
Oh no, I admit I'm not Dr. Data and I don't have a YouTube video yet, but yes, I'm getting there.
Music video, yes. Yes, we'll do anything to educate on predictive analytics, machine learning. We have the Predict This rap music video, very, very educational, and a brand new machine learning rap music video called Learn This, embedded in the middle of the course series on Coursera. Free to access, 2.5-minute best educational machine learning rap music video, stuck in the middle of the 141 videos on that.
Okay. So you're a singer-songwriter. You got me on that one. So you may have a little more passion, but I'm getting there. I'm getting there.
No,
I got the book coming out. Yeah, I know.
You got to write a rap. You're not educating on machine learning unless you write some prose that rhyme.
Hey, I've already said no TikTok dances, and I don't think my audience wants to see me rap either. So I'll leave it to Dr. Data to do.
I mean, I beg to differ, but okay.
So getting back to the predictive analytics machine learning. So, I mean, we threw out a lot of terms there early on to kind of break it down then. I mean, let's take away the myth of some of these terms. And you mentioned data quite a few times. I mean, let's break down that myth of the word big data, because a lot of it, what you talked about, it's a lot of data.
Well,
go ahead.
Like a 2-minute description of how machine learning actually works under the cover, right? In 2 minutes,
Go.
Right? So data is not boring. Data is interesting because it's a list of things that have happened. It's a recording of history. It encodes the collective experience of your organization. So this is a process of learning from experience. And what gets learned from analyzing those things that have happened in the past, where you know what happened, what the outcome was. You know how many ice cream cones were sold in the third quarter, which of your customers canceled, which direction a political election went, which transaction turned out to be fraudulent, which credit card holders turned out to be bad credit risks. You know all this. That's the experience. So you learn from that data. The number crunching methods derive patterns. And the patterns, depending on the method, are pretty intuitive and understandable. So they could be business rules. Like if a customer lives in a rural neighborhood and has these demographic characteristics and has exhibited these particular behaviors, if it's like a long English sentence, then they have, let's say, a 4 times more likely chance than average to buy your product, right? Which still may be a relatively small chance, but when you're improving something like mass marketing, a small, finding a pocket which has a 4 or 5 times more likely chance of behaving in a certain way or having these outcomes, making these purchases, is a dramatic improvement and has a dramatic improvement to the bottom line metrics of that large scale process, whether it's in marketing, fraud detection, credit assignment, and all different kinds of business operations. So I guess I might have gone 2 minutes and 25 seconds, right?
I lost track. It was just so entertaining. I was listening. I lost track of time. So when you're talking about that example right there, you pretty much talked about looking at historic events, historic drivers that we can identify, and putting probabilities to that. I mean, like saying, okay, this percentage occurs, this percentage occurs. A logistic regression is pretty much what you're talking about there, right?
Logistic regression is one of the methods. Logistic regression is just a weighted sum with a little bit of fancy math added onto it. A weighted sum, literally, that each factor, each input to the model, each thing you're considering about, let's say, a consumer, demographic aspects, how many purchases they made last quarter, et cetera, that each of these aspects, which are called an independent variable, gets a weight. So their relative importance simply is a bunch of weights. And then it's a weighted sum, and then you do this little nonlinear transformation that helps the thing work better. But for the most part, it's all about the weighted sum. And in fact, a neural network, everyone hears about deep learning.
Yeah.
Deep learning is a kind of neural network, but neural networks in general are actually just composed of those types of weighted sums. You just sort of build it up to a big, complicated mathematical soup, which can be very difficult to decipher, even for the inventors of the method, right? Even for the scientists who created neural network algorithms that do this. But the actual building of it is modular, right? So if you look at the way people build a bridge, you'll see all these trussels under the bridge, and the way they work, and they're these little, often triangular shapes, and we know how they support structure, right? So each little part, each component is very simple. You build it up into this massive system. It's very complex to understand at once, but we know it works, and you can measure how well it works. People drive across the bridge, and it holds up with a car, and likewise, you can see how well these complex models work in a very simple way. You just try them out over many examples and see how well it predicts.
So we just demystified neural networks, and that's why I was leading you, beat me to it, type thing. So real quick, back to that data thing. One of the things we talked about in data, I want to make sure when we're talking about a lot of data, it can come in different ways. It can be a breadth or depth of data. So I mean, you could actually have a lot more features, or what they're calling drivers, different things, predictors that you're looking at, or you can have a lot of the same feature and everything. So there's really a difference when you're looking at a lot of data, can mean different things and has different impacts to a model then as well, correct?
Yeah, absolutely. So you could just think of the learning data, the list of historical examples where you already know the outcome, right? That's the value. That's why there's so much. The thing about big data isn't just that it's large physically, the volume of it, right? Because there's always twice as much today as there was yesterday. So the word big is all just relative. But what is absolutely big is the excitement about it because of its value. And the value is that we have these historical outcomes. We know how things went. And what we also have is a lot of pieces of information, those independent variables, and there are columns. So the data, the learning data, which technically the technical term for learning data is training data, go figure, right, is just a two-dimensional table. So it's a bunch of rows. So it could be an Excel spreadsheet, although typically you want more advanced software than Excel, but the concept's the same. It's just a two-dimensional table, and each row is an example, and each column is one of those different independent variables, those different factors, demographic and behavior, that is known about each individual. So the data potentially does get quite wide because there's so many different aspects, factors known about each individual that could help predict, that could provide value as input ultimately to the model, the thing that's learned from crunching that data. So we want the data to be very, very wide, even if ultimately the system's going to decide that only a small, a handful, a couple dozen of those factors will actually get used, but you never really know which ones those will be until you try it out. So you just throw in a whole bunch of stuff and see which aspects turn out to be most predictive.
Okay, so let's get to that point then. Just throwing in, because I don't want to overfit the models, have too many features. How do I know exactly which model is going to work? And what are we going to do? What's a predictive model look like then?
Right. So the overfitting question is sort of the big question, right? I mean, it might find patterns in the data that don't hold in general, and therefore it's failed. It hasn't found an actual truth that's going to help you predict in the future. It's just found arcane aspects of this particular list of examples, even if it's a really, really long. So I said, I'm making the point that the data is really wide, and you're making a valid point, was, well, if it gets too wide, then you're giving it so many opportunities to find little weird arcane things, otherwise known as overfitting. So that even if it's also really, really long, even if there's tens of millions of examples, for example, it's still has the potential to overfit, to find patterns that don't hold in general. Now, there's a lot of ways to try to fight against the potential to overfit, but the bottom line is extremely simple. Whatever strategies are in the algorithm to help avoid it to overfit, the only way you know, and the way that you can be totally sure that it hasn't overfit, is simply to test the resulting model over a bunch of examples that were held aside, that were quarantined, that were not used during that number crunching, during that learning process. And that's the standard. That's not just a best practice, it's the only practice. All the software does this typically automatically, even without you asking, although you can specify how to do it. But it might hold to say about 20% of the data aside, and then you're foregoing the value of that data for the learning process, right? You get that much less data to actually learn from, but you have the absolute necessary requirement fulfilled that whatever you do learn from, let's say, like 80%, is now validated over the separate held aside data, which is called test data.
All righty. So the different models, I want you to hit on ensemble modeling real quick, because when we're looking at something that, you're talking about simplicity and being able to find the best features, find the best model. Ensemble modeling actually can help you. And it's held up a lot in those Kaggle competitions and things of that sort as well. So you want to explain a little bit about ensemble modeling then for the audience?
Yeah, sure. So an ensemble is when you take a bunch of relatively simple models, like a simple logistic regression, which is a weighted sum, and or a decision tree, which is a way to encode those if-then business rules we mentioned earlier. But you take a whole bunch of those models and you basically just have them all collaborate. You have them all vote, or you take the average output of all of them. Basically, it's totally analogous to this wisdom of the crowds concept that happens with people. So if I show you a big can of marble or a glass jar of marbles, and I say, can you guess how many marbles in here? The winner, whoever guesses closest is the winner. It's very difficult. You're looking at this jar of marbles with your eyes, and you're trying to figure out how many marbles are in there. But if you get a lot of people to guess, some will guess way too high, some will guess way too low. But typically the average guess is a good guess, often better than the best individual guess. So the group of guessing people as a collective exhibit this emergent so-called collective intelligence, right? And it's the same thing when you have a population not of humans but of models, even if the models are super simple. So that's what an ensemble model is. So it kind of smooths out the edges in the sense that if you did something like a decision tree, which is a way to summarize a bunch of if-then rules. Well, if I have this list of, let's say, 50,000 examples, and it grows the tree, it creates a bunch of rules, learning from that data, it typically does a pretty good job, but it's a little brittle in the sense that if I change the data even just a little bit, there's a possibility that the resulting model would change a lot, just because of all the boundaries, right? If a few boundary cases changed, the whole resulting model might get a lot better, a lot worse, just from those little changes. And we don't really want that. We don't want that brittleness. But if you perturbate the data a little bit randomly, create a new model, a new, let's say, decision tree, and then do that repeatedly, create a whole population of trees and have them kind of collaborate, have them all vote rather than just relying on one model, then that overall process is much more robust, much less brittle.
Okay. So then the last thing when we're taking apart predictive analytics machine learning, the other thing I always say is it's more forward looking. Opposed to just looking at historic, level and trend. This is a more forward looking, because you are looking at those other features, width of data set, data that you're looking at. So, then it gets into things like uplift modeling, or what persuasion modeling, I think, is the other word for it. Things of that sort. Things that can really not only, predict what the future is, but help create a future going forward. Is that really that next stage then for predictive analytics?
Yeah, uplift modeling, also known as persuasion modeling, yes, that's the other word for it, is a better option for many application areas, especially in marketing and, let's say, political elections, because you're predicting whether the individual would be persuaded, whether you would change the outcome with this marketing contact. So instead of just predicting of all the customers who I actually apply the marketing treatment, let's say I spend $2 sending them a marketing brochure, which ones are most likely to buy? That doesn't necessarily help me decide who I should send a marketing brochure to. Because what I want to do is not just send the one based on who's going to buy if I send it. I want to know who's going to be more likely to buy if I send it in comparison to if I didn't send it, right? Does the marketing treatment actually help? Does it have an impact? And the same thing with driving which campaign volunteers knock on the door for a political election. And Obama's re-election campaign 2012 very much used uplift modeling / persuasion modeling. So this proves that you really did read my book, because it's the very last chapter. But I saved the best for last in a sense. And the same thing, it's also covered at the end of our Coursera course series, Machine Learning for Everyone. So the thing about uplift modeling is its potential to do much better than standard predictive modeling or machine learning is huge. but it also is more complex and has additional data requirements because you need to have a control set, right? So most applications of predictive analytics, that is to say, most of the time when you use machine learning for business, you're operating on found data. So found data meaning data that wasn't actually collected for the purposes of machine learning, but it's big data. It's all the data that's being collected just as a side effect of conducting business as normal, right? So you know that you did all this marketing last quarter, and you know which of those customers did and didn't buy. That's data that's sitting around, right? That just was organically collected, organically in the sense that just as a normal matter of conducting business, and now we're making use of it. If you want to move to uplift modeling, you have to conduct experiments. That is, you have to have a control set. So in the case of marketing, you need to market to a bunch of people and track who did and didn't respond. That's already normally done. But then you also need to purposefully not market to some control set, some evenly distributed sample of customers who you're going to withhold the marketing treatment, but then also track who did or didn't make the purchase anyway. Or in political elections, who did vote for your candidate or didn't, whether or not they are applied to a phone call from a campaign volunteer. Same concept. So it's more complex, but it's a fascinating area.
And yes, I did read your book. I read it a couple times already, and I highly recommend people in the audience, if you want a good introduction before my book comes out to predictive analytics, this is it's a good, entertaining, conversational type of read. Highly recommend picking this up as one of your must reads, especially during the season coming in, the COVID season when you're sitting at home. Last question then for you. I wish I could keep going, but the audience only has so long of attention span, and I can only go so long as well. So last question for us then, it's those noobs, the people like me that want to get started in this, that have this passion, or we've now hopefully sparked that passion in them about what predictive analytics is, and they want to learn more type situation. How do you recommend? I mean, they're a demand planner, a forecaster in a company. How do you recommend they start gaining that knowledge they're gonna need in a few years?
No, that's a great question. And I mean, my first answer will be to once again plug the Coursera course series, because I'm addressing an unmet need with this thing. Most machine learning trainings are technical. Either they're hands-on or they're abstract academic with regard to the algorithms, the machine learning methods themselves. But the fact is, there's another side to machine learning if you're going to actually make business value out of it, which is the whole organizational process, right? The way you're positioning the technology so that it's not just a cool, elegant model that's nifty, but it's actually actionable and will actually be deployed, that is integrated into your existing operations, that they'll be changed and improved. So what we did with Machine Learning for Everyone, and the information about free access is at machinelearning.courses, is holistically address both sides. So an accessible overview of the underlying methods that we've been talking about, machine learning methods, but then also all the organizational requirements, the planning, the green lighting, the staffing of the analytics project, the data requirements and how you prep it, which is not rocket science, but is very involved on a technical level, has certain particular requirements, that table we were talking about. And sort of all the ins and outs and pitfalls about how do you understand how well a model really did, and how can you be secure that it's discovered something truly of value that will be actionable and that'll hold up in new situations.
Well, thank you very much. I really enjoyed this conversation. I said I'll probably have you back sometime, talk again, because I just enjoy talking with you. And so someone that almost shares my passion with predictive analytics is hard to find. So I appreciate you coming on board and kind of raising up your passion a little bit for what we do.
Thanks for the great questions and including me. Good talking.
It was great talking with you, and we'll speak again soon.
Awesome. Thanks, Eric.
Thank you. Not surprisingly, that was a wonderful discussion. I knew I'd enjoy talking with him. He does make predictive analytics understandable and entertaining. And that's why I really wanted to have him on board to help explain exactly what we're talking about with predictive analytics and hopefully entertain you along the way. Predictive analytics. If we really wanted to sum up that as a definition for business purposes, it's a process and strategy that uses a variety of advanced statistical algorithms to detect patterns and conditions that may occur in the future for insights into what will happen and to help support various business needs. All right, we talked about every business decision is based on that forward-looking projection. It's a forecast. And if we can do it better, that's what we're all about. And predictive analytics will help us do that better. So really distinguishing what the difference is. He had a great definition talking about the finite and probability versus, the deterministic. I mean, he has some great insights that he talked about with predictive analytics. The way I'm going to simplify it is really based on three basic things. This makes it different. It's one, it's more and different data. We're not just looking at our internal data sets anymore. That's not going to get you where you need to go, especially during times like COVID or any type of things that we're going through that shocks to the system where you really understand your consumers and market better. To be able to do that, you need to start looking at external drivers, external data. You need to start looking at things that really drive your business and drive consumer behavior. Those are the different data sources. And he talked about the wide, talking about all the columns that you're looking to be able to forecast. We need to start looking at more data, more variables to be able to bring into our modeling. That's the one first and foremost. Data drives prediction. And looking at more and different types of data is really one of the major characteristics of difference in predictive analytics. Second, it's more and different models and algorithms. It's not just your mama's moving average. You have to start looking at things that really look at correlations, start looking at things that really bring different models together, start looking at different drivers, start looking at different types of machine learning that will help your system identify and learn from behaviors and patterns to be able to do better predictions going forward. So it's the more data, different data, more and different models as well. And a lot of them are in those supervised or even unsupervised type of learning models. And finally, the last piece, what really differentiates predictive analytics from standard business forecasting or what we've been doing for years with a lot of success, but to really get to that next level, it needs to be more forward-looking. And believe it or not, what we do is not exactly groundbreaking and forward-looking. If we're looking at past order history and looking at the level, trends, seasonality, noise, and extrapolating that forward, you're making some assumptions there, yes. And it's also reactive to what has just occurred. If we can start understand the whys, if we can start seeing the drivers, now those can sometimes be turned into leading indicators that are truly more forward-looking. You're now driving your business with something that is more sure has happened in the future or more correlation to what may occur in the future. So predictive modeling, by its nature, a lot of times, is more forward-looking. So if I had to break down the difference, it's more different data, more different algorithms, and it's more forward-looking. That's the basics of predictive analytics. It isn't rocket science, though. If I can do it, you can. And I want everybody to get on board and start learning more. He mentioned my book coming out, and I appreciate that plug he gave him. And I'll give you another little plug. In about a month, I'm going to have a book coming out. That's going to be the topic of that podcast. And you've done a great job, audience. Every person I've had on with the book, I keep getting feedback from them and you saying, I bought that book. Please, to that, buy Eric's book today. And then you're going to check out my book as well, because it's going to make business forecasting and predictive analytics easy, understandable, something you can grasp, something you can hold on to and make it more enjoyable and better going forward. So this comes to an end of another IBF On Demand podcast. My name is Eric Wilson. You can find me at eric@ibf.org. It's eric@ibf.org. Check out Arkieva as well. We're talking about machine learning. They just came out with a new Swiftcast. Actually utilizes machine learning in developing an ROI for exactly what you may be able to get with different types of models, different types of data, how you can look at your data set and actually look at an ROI to that as well. So check out Swiftcast. It uses some machine learning as well. And you can find that at Arkieva's website. So please Continue to listen, like, share, subscribe. Continue to be part of this family. Help us grow this community. Over 2,000 is the next goal. Let's see if we can hit it before the next podcast. With that, I want to thank everybody. Thank Arkieva one more time. Thank the audience. Thank everything. And don't forget, wash your hands.